How long do you think you'd survive if you woke up on Earth 4.5 billion years ago? 10 minutes? An hour? Take your worst guess and cut it down. Because the honest answer is closer to seconds. Not because of some monster hiding in the dark. Because the planet itself, the one you're standing on right now, wasn't yet a place a human body could exist in at all. For most of Earth's history, this wasn't a hypothetical planet with occasional rough patches. It was a molten, poisonous, radiation-soaked world actively hostile to almost everything you're built to need. And the strange part isn't that you die instantly. The strange part is exactly which problem would kill you first. Because there's a longer list than you'd expect. And the order matters. Let's actually walk through it. One lethal problem at a time. Because each one reveals something different about how impossibly lucky you are to exist at all. Problem 1. There's no air to breathe. In the way you understand breathing. Earth's earliest atmosphere, during a period geologists call the Hadeanian, named after the Greek underworld for a reason, was overwhelmingly made up of gases like carbon dioxide, nitrogen, and volcanic sulfur compounds, with essentially zero free oxygen. Planetary scientist Kevin Zahnle, who has spent decades modeling the chemistry of early planetary atmospheres, has described this period as chemically closer to the toxic air of modern Venus than to anything resembling breathable Earth air today. You could inhale as deeply as you wanted. Your lungs would fill with something your body has no way to extract usable oxygen from. Within a couple of minutes, you'd lose consciousness. Within a few more. That's it. So here's the first real question worth sitting with. What would it actually take to fix that problem? Not for you, specifically, because you don't have that kind of time, but for Earth as a whole. The answer took roughly 2 billion years. And it wasn't engineering. It was biology. Specifically tiny ocean-dwelling microorganisms called cyanobacteria, which began performing photosynthesis and releasing oxygen as a byproduct on a scale that slowly, gradually changed the entire chemical makeup of the atmosphere. Geologists call this shift the Great Oxidation Event. And it didn't happen fast. It happened over hundreds of millions of years, one microscopic organism at a time, until oxygen finally accumulated enough to support anything like you. The solution to problem 1 wasn't a solution you could apply in the moment. It was one that required almost half of Earth's entire existence to unfold. Problem 2. And this one might kill you even faster than the air does. There may not be reliable liquid water yet. At least not everywhere. And definitely not anything close to safe to drink. For a long time, scientists assumed the earliest Hadean Earth was simply too hot for liquid water to exist at all. A molten surface baking under a young, chaotic sun. But research led by geochemist Elizabeth Bell at UCLA, studying microscopic mineral grains called zircons preserved in the Jack Hills region of Western Australia, some of the oldest known materials on Earth's surface, found chemical signatures suggesting liquid water may have existed in isolated pockets as far back as roughly 4.4 billion years ago. That's a genuinely strange, counterintuitive finding. It means the picture of early Earth as a uniformly hellish, bone-dry inferno the entire time isn't quite right. There may have been brief, isolated windows where liquid water pooled somewhere on the surface, tucked between the chaos. But even if you found one of those pockets, you wouldn't want to drink from it. The water likely would have been thick with dissolved volcanic minerals, acidic in places, and utterly unfiltered by anything resembling the biological and geological processes that clean modern water today. Drinking it wouldn't quench your thirst safely. It would poison you slowly while you were already suffocating from the air. Problem 3. And this is the one most people forget entirely. You have no protection from radiation. Earth's protective ozone layer, the thin shield in the upper atmosphere that blocks the most damaging ultraviolet radiation from the sun, is itself a byproduct of that same oxygen buildup from cyanobacteria. No oxygen yet means no ozone yet. Which means the surface of early Earth was bathed in a level of solar ultraviolet radiation that modern skin, modern eyes, and modern DNA were never built to withstand for more than a few minutes at a time. Forget sunburn. This is DNA damage accumulating so fast, it would overwhelm your body's repair systems almost immediately. You wouldn't need the poisoned air or the acidic water to kill you. Standing in direct daylight alone would eventually do the job. So let's actually reconstruct what a single day would look like, because it helps to picture this concretely rather than abstractly. You open your eyes on a rocky, mostly barren landscape lit by a sun that looks slightly smaller and dimmer than the one you're used to. Part of something scientists call the faint young sun paradox, where the early sun burned roughly 30% less brightly than it does now. And yet somehow the planet was still hot enough in places to have active volcanism reshaping the surface constantly. The ground beneath your feet is likely volcanic rock, still cooling from an earlier molten period, riddled with active vents releasing sulfurous gas. Above you, the sky is a hazy, yellow-brown haze thick with volcanic ash and gases. Not the blue you know. And here's a detail that would genuinely disorient you before any of the chemistry even gets the chance to kill you. The day itself is shorter. Much shorter, because the moon, formed from a colossal collision believed to have happened in Earth's early history, was originally far closer to Earth than it is now. Its gravitational pull spun the planet much faster, meaning an early Earth day may have lasted somewhere around 6 hours instead of 24. You'd barely finished taking in the horror of your surroundings before the sun was already setting again. Now here's the counterintuitive twist, the part that flips the entire premise of this thought experiment on its head. You, specifically, couldn't survive this world for more than a few minutes. But life, in some form, may have started finding footholds here astonishingly early, possibly not long after conditions became even marginally survivable for anything at all. Some genetic and geological evidence suggests the earliest simple life forms may have emerged less than 1 billion years after Earth itself formed. An almost absurdly short window, given how hostile the environment still was. The planet that would kill a human being in minutes was, at nearly the exact same time, already quietly incubating the very first steps of the same evolutionary chain that would eventually produce you. That's the strange part worth sitting with. This wasn't a planet waiting patiently for conditions to become perfect before life dared to show up. Life appears to have started elbowing its way and almost the instant survival became even theoretically possible, adapting to brutal, narrow, dangerous conditions long before anything resembling comfort existed. The first organisms that took hold here weren't thriving. They were barely enduring, squeezed into whatever microscopic pockets of tolerable chemistry they could find, in a world actively trying to erase them at every turn. So what's the actual solution to surviving 4.5 billion years ago? If you had to name one, there isn't a version where you personally solve it. No amount of preparation, no imaginable equipment, gets a human body through air with no oxygen, water thick with acid, and radiation with no ozone shield to block it. The only real solution was time itself, measured not in minutes or years, but in billions of years of accumulated microscopic change. One generation of ocean bacteria after another, slowly rewriting the chemistry of an entire planet until, roughly 4 billion years later, it finally became a place capable of supporting something as fragile and specific as you. Here's the mirror, and it's worth sitting with before you go. Every single breath you're taking right now, effortlessly, without thinking about it, is the end product of roughly 2 billion years of unglamorous, invisible microbial labor that nobody was around to witness or appreciate at the time. Every sip of water you drink safely is the result of geological and biological filtering systems that took billions of years to develop into something your body could actually rely on. Every moment you spend outside without your DNA unraveling under direct sunlight is thanks to an ozone layer that is, itself, just a leftover byproduct of that same ancient oxygen-producing process. None of this was built for you specifically. It just happened to eventually become livable. And you happen to exist on the exact right side of that 4.5 billion year timeline to benefit from it. How long do you think you'd survive if you woke up on Earth 4.5 billion years ago? You already know the answer now. Minutes, at best. But maybe the better question isn't how long you'd survive back then. It's how many billions of years of quiet, patient, invisible change it actually took to make the world you're standing in right now survivable at all.